Hi to all. In this brief video, we will cover these questions of practice quizzes, which are one is on the euro-dollar deposits and the amount of interest we get, and the other one is on the forward rate agreement. So when we look at the euro-dollar deposits, these are deposits in which we get the interest basically as an add-on rate. So we are no longer using this 1 plus r to the power of time, but we are just simply having this interest rate that will be paid, and that interest rate is going to compensate us for the holding period, right? So let's just use all of the values. Let's just type all of the variables we are being given here, right? So we have we are opening a 90 days euro-dollar deposit, right? So time is 90 days. Next, the amount deposited is 16,013, and the rate is 5%. So actually, this is very straightforward, very simple. Number one, the amount of money that we will receive when we close this this euro-dollar deposit. We will receive the amount of money we deposited initially times 1 plus this rate, and then that's it. Now, one important thing is that this rate is annual, and the period of time we will have the deposit, the euro-dollar deposit, we will maintain it is 90 days. So as we have done before, we need to, rather than raising this to the power of 0.25 in this setup, in this setting, what we do is we multiply this by 90 divided by 360, or in other words, this divided by 360. Okay, and another way you could have done this is 3 divided by 12, the same way we did before. Now, this is how much money we will get upon maturity. So how much interest we will have earned is basically, well, this what we withdraw minus what we deposit, and then that's it. That's the amount of interest. Now let's look at this forward rate agreement, and for that purpose, I'll quickly do this. So we have in this case a 3/6 forward rate agreement. This means that the overall duration of this forward rate agreement is 6 of the whole transaction, right? The 6 months. So this transaction, we will split it in two. Number one, let me use these something like this here. So number one, we have this 6 months rate, but this 6 months rate, we could split it like this in two as well. So we could do, if we are depositing money for 6 months, we could do it basically in two ways. Number one, we could deposit today and then keep that money deposited for 6 months. Number two, we can deposit today in a 3-month the euro-dollar time deposit, and then when that time deposit reaches maturity, then we could basically roll it, or in other words, we could just get into another one. We could deposit it again in another 90 days euro-dollar deposit at that point in time. The risk when we do that is that we may have a rate. Let's assume it's the 3-month rate is 2% here, and then we could have a 2% here as well, but rates may go down to 1%. And if we have this concern, then we may want to lock this rate that we will have in the future as well. But long story short, let's focus on this forward rate agreement. Let's assume now that this 6 months rate is 5%, and now we know the 6 months rate and we know the 3 months rate, which is 2%. So what happens is we know these two rates because both of these deposits would begin today. So because both of them would begin today, the rates are already revealed because the rates are known. What we do not know is, well, what happens if you need to deposit money for 3 months here? You need to deposit money for 3 months and you do not know. We don't have certainty about what the rate will be. So we know that the 3 month, a 90-day euro-dollar deposit is offering basically a 2% rate because we are giving this. But we cannot have we have no guarantees that by the time we reach the end of a first deposit, by the time we are past these first 3 months, the rates will remain the same. So then what we can do is we can lock this rate with a forward rate agreement so that we eliminate, we resolve this risk that this interest rate may go down. So the way to do it is using the formula, which is in essence 1 plus the longer rate divided by 1 plus the shorter rate. And by longer and shorter, I'm just giving you this in a very intuitive way. I mean longer, I mean the one with the longer duration, and by shorter, I mean the one with the shorter duration. And once we have all that, then we are going to multiply this. We're going to, divide this. We're going to annualize it. So let's period. And then we analyze. So the way we analyze it is this rate we are going to get, we will get it for it will be a quarterly rate in this example, because this duration of this deposit here, if we wait for 3 months and then we open this deposit at this point in time, we would open it for 3 months only. So then whatever the solution of this problem is, we will get it in quarterly terms in this problem, according to this in this setup. So then we analyze it by dividing by 90 divided by 360 by dividing by 0.25, right? Okay, there we go. So step one, let's convert this rate, 6 month rate. So annual rate, we have the 6 months LIBOR, we have the 3 months LIBOR, and then we have this is 5%, this is 2%. So we can then calculate something that we will call per period rate. So because this is a 6 months rate, let's multiply this by 0.5. And because this is a quarterly rate, let's multiply this by 0.25, right? So or we're dividing this one by 2. We're dividing this one by 4 in simpler terms. Now we want to find the FRA rate. And this rate will be 1 plus the longer rate, but we will use the per period, divided by 1 plus the shorter rate, but we're going to use the per period rate, and then minus 1. Basically, that is the same formula that is given in Canvas, right? So then basically that's how. And yeah, one important thing, because this rate was coming up negative, is that I was choosing cell 120. it should be cell C12, right? See, I had C120 before. So now this FRA rate is 0.0199. That we can have it in percentage as 1.99, but then we need to analyze it. And the way to analyze it is because of the setup of this problem. And one important thing is that this problem may be different. For example, this may be a 1 year longer period, and then this could be a 3 months rate. Then in that case, what we would be solving for a 9-month rate. If this is instead 1 year and then this is 6 months, this initial period here, then we would get the solution in a 6 months rate, right? But in this specific case, this is the overall period is 6 months, and then this initial period here that we already know, we already have the rate for this period is 3 months. So then this period that corresponds to the solution will be also a 3 months rate. It will be also a quarterly rate. So in order to analyze it, right, we divide by 3 divided by 12, which is the same as 0.25, right? So there we go. And once we do that, then we end up, and we can format this as a percentage, we end up with our solution, which is 7.96, and that is the solution to our problem. So I hope this was helpful. At least you were able to solve this question in the practice quiz and in the quiz. And let's just keep in mind that if for any reason this, like here we are analyzing, and when we analyze it, right, we are dividing by 0.25 because we are assuming this is quarterly. It is quarterly because the longer rate is 6 months minus shorter rate, which is 3 months. Then we end up with this FRA, this future rate, which is 3 months, right? So that's why we are dividing by 0.25, because the solution here is given as a quarterly rate. That's what we see right here. Okay, so I hope this was helpful, and please feel free to contact me if you have any questions. Thank you for your attention.